Okay, let me just quickly explain it now then, because you guys can hear me properly. I won't play the video, I'll just go sections by sections. So diffraction, guys, all it means is a spreading out of waves. How? Through a gap. As you can see here, imagine water waves, yeah? They spread out like this, okay? Water waves through a gap. Now, if we have the example of light going through a doorway, okay, we won't be able to see the light on these sides if the light is coming through the doorway, so we remain dark here, okay. However, we will be able to hear the sound waves, of the light, but we won't be able to see it on this part, so we'll be able to hear it, and there's a reason why. I'll come back to that reason in a minute. So all diffraction means is that it's the spreading of waves through a gap. Now, there are some factors. So now, if the wavelength is equal to the height or width of the gap, then there'll be loads of diffraction. Okay. However, as you can see in this example, yeah, there's loads of diffraction. Why? Because the wavelength, the length between here and here, is similar to the gap. Okay. However, in this example in red here, if the wavelength, as you can see, is very, very small, it's not the same as the height of the gap, then look what happens. There isn't much diffraction. It's not spread out as much, yeah, as you can see in this example. This just means not equal, yeah, that symbol. So there's only little diffraction that happens. Why? Because of the wavelength. Hopefully that makes sense. So that's why in our example of the door, we can hear the sound from the light bulb. Why? Because the wavelength is similar to the size of the gap, so sound waves will diffract. However, light waves, they're not similar, and therefore they do not diffract. So that's why these parts we can't see light, and the light just comes basically straight through. It doesn't diffract on the sides, okay, in that example. So that's the reason why we can hear the light, but we can't see it on these edges here. So it's not just gaps. Right, so just again, so the sound waves act like this, so we can hear the light from the light bulbs. However, the light itself, if you imagine this is a doorway, the light goes straight, okay? So we can't see the light on the edges, so it's dark here, but the light goes straight. So you can actually test that at home. Okay, so now it also happens on edges. So imagine these are radio waves, okay? So the wavelength of the radio waves, wait, can everyone hear me still? Oh, I'm just talking to myself.
Yes, you can hear.
Okay, brilliant. So the wavelength of the radio waves, for example, are equal to the width of the edge. So imagine this is a hill and there's a house at the bottom of the hill. As you can see, the wavelength is very similar to the width of the edge. So it's not only gaps, it's edges. So what will happen is, whoops. Okay. So because it's similar to the edge, there'll be lots of diffraction, and the house will be able to receive these radio waves. However, if there are microwaves, for example, from a satellite, which, as you can see, they don't have a similar wavelength to the edge, the width of the edge, the house will not be able to receive these signals. Okay, so it's all dependent upon the wavelength. That's how diffraction works. If there's a similar wavelength to the gap or the edge, then there'll be loads of diffraction. Diffraction, all it means is the spreading out of waves. However, if the wavelength of the waves are not similar to the width or height of the gap or the edge, then as you can see in blue, the diffraction will be very, very small or minimal. Okay, so hopefully you guys understand that now. So, okay, well, Hamid Ghalim's here. Please remind me, Hamid, to put you in the register at the end. Right, guys, so if you now have a look at your diffraction classwork on your assignments. Everyone on it?
Yes, yes.
Good. So what you need to do now, hopefully everyone can see my screen. What you need to do now is add the correct words in the gaps. So do that now. Do that now. You should know all of these words. The only one reciprocal you may not know. All that means is 1 over. So you remember in our equations, it means 1 over. Okay, so I'm going to give you 1, 2, 3, 4, 5, 6, 7, 8. I'm going to give you about 3 minutes. 3 minutes to complete, guys. And in the meantime, I'm going to ask Khalid. Khalid, does your mic work? I don't think it does. Mohammed Yusuf. Does your mic work? Well, Abdul Rahman Jasim, somebody? Can somebody explain what diffraction is to me?
Yes, I can.
Who's that? Abdul Rahman?
Diffraction is when waves spread out after passing through a gap.
Yeah. Anything else?
Mister, the first one is energy, yes?
Say again?
The first one is energy, a wave transfer energy.
Well, Abdulaziz, don't give it away. Don't give the answers away. Complete it. We'll go through the answers in about 2 minutes. Okay?
Okay.
All right, so try your best now. Yes, Abdul Rahman, you were saying?
It is when the waves spread out when moving through a gap.
Yeah, okay. Anything else you learned?
If the gap is similar to the wavelength, it will spread more. But if not, it will not spread.
Okay. Won't spread as much, yeah. That's correct. Could you give me some examples?
Yes. When
Go
we
on.
open the door,
Mm-hmm.
we hear only the sound of the light bulb, not the light. We can't see the light because the sound is wavelength is similar to the gap, but the light is not similar to the gap.
Good. Excellent. Well done. Right. Give me a thumbs up, guys, if you've finished. Ah, Mohammed Yusuf, what does he have to say? Diffraction is the spreading out of waves. Yes. It's when waves pass through a gap, Khalid. Yeah, okay. Good. I'm glad you guys understand that. Give me a thumbs up when you finished. Okay, Umar's finished. Good. So Umar, give me the first one. Energy. Abdelaziz already said it. Come on, guys, help me out. Let me hear the answers. Or type in the answers at least. The next one. A wave transfers energy without the movement of
matter.
Matter.
Of matter. Good. From one place to another in a something wave.
Transfer.
Transverse wave. The particle
Vibration.
vibrations are perpendicular to the direction of the wave. What does perpendicular mean?
Mr. Wait, I'm copying.
What does perpendicular mean? Hamid, you just need to go on assignments. It's on assignments.
Yeah, I got waves. Which one? Go and say.
Diffraction, waves diffraction. Come on, guys. Frequency is equal to the number of waves. Oh, sorry. Did we say what perpendicular means?
Opposite of reciprocal. That knows.
Simple explanation. What does it mean? Who remembers? Come on, guys. It's 90 degrees. The angle, remember? 90 degrees. Anyway, frequency is equal to the number of waves produced by a source in one.
Yes.
In one what? Let's see the comments. Yes, hardly got it. Creating 90 degrees. Come on, what's the next one, guys? Come on. Frequency is equal to the number of waves produced by a source in one.
Mr. I didn't download it. Do I have to download?
No, I think you can just do it there.
Okay. Because I'm scared if I do it, it will become like all the people see mine.
No, it won't. It's only for you. Come on, guys, in 1 second. 1 second. Frequency in 1 second. So time period is equal to the something of the frequency. So this is to do with the equation. You can tell me. Oh, okay, guys. You were typing it in. Yeah, second. So what's the next one then? What's the next one after second? Come on. You guys should be ticking your answers if you got them right, by the way, so I can see when I'm have a look at your assignments. Yes, reciprocal. Thank you, Khalid. The speed of a wave in meters per second is equal to its equal to. You can type or tell me on the mic. Frequency, Khalid says.
Wavelength.
No, wavelength. In meters. Meters. Multiplied by its frequency in hertz. Come on, Khalid. The clue was there. Right, guys. So, I just want to show you guys something.
Mr. Can you go back? I didn't see you. Only I want the last word.
What you can do is just have a look at the video, Hamid, in your own time, and you can catch up. Okay? Right. So, what I wanted to show you guys is before I let you do the rest of your assignment, just wanted to show you this and actually share it with you. Let's share the link with you guys. Maybe you can have some fun. So I'm just sharing the link in the comments if it loads. I don't know what happened there. There we go. It looks like my team's crashed. Can everyone still hear me?
Yes.
Yes.
Can.
Okay. Yeah, my team's crashed. What you guys can do is type now in Google Chrome www.falstad.com/ripple RIPPLE /. Yeah, it seems like my teams have crashed. Can everyone still hear me? No?
Yes, Miss.
Yes. Yes.
Ah, okay.
Mr. Can you say it again?
Say again?
No, can you say again for www dot after what?
Okay, so www.falstad.com/RIPPLE again.
So can you write it in comment?
I'm really trying. My teams have, I don't know what happened to teams. It's all frozen and blocked and everything.
Abdurrahman Jassim, he wrote it.
Did he? Okay, great. I can't seem to access anything. I'm gonna leave and come back in, I think. Oh, Assalamu alaikum. Hopefully you guys are messing around because it's still recording, by the way.
No, everyone has been quiet. Nobody talk.
Alhamdulillah, good. Okay. So did the link work?
Yes.
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 Okay, brilliant. So let me just try and share it with everybody, just to show you how we can kind of manipulate and mess around with it. Where is it? Well, Sarah, I'm not going to put you present for the first lesson. And you came late to the second. Okay, ripple tank. Hopefully everyone can see. Not yet. Yeah. Okay, cool. So you can see the waves here. You don't have to worry about these for now, because you can have like more than one wave. As you can see, you can have 4 waves coming together. This is diffraction, what we learned today, through a small gap. Double slit, so 2 gaps. Triple slit, yeah. So you can see all the different types of waves and their variations. So we'll just concentrate on sound waves. You can change the color scheme as well if you like. You can make it look as cool as you like, up to you. You can have a 3D view. You can speed it up. If your computer doesn't crash.
Start.
Yes.
When you finish recording, can you send it on the group so I can study from it?
Yeah, it automatically saves. Don't worry.
Okay.
There's all the videos from before you should see. You can have a look at the frequency as well. You can increase the frequency. Yeah, this means the number of waves per second, as you can see. Yeah. You can change the brightness. Okay. So what I want you guys to do within your assignments, I want you to create a wave like I've done here, up to you how you want to do it. Could be anything you like. And screenshot it. Add, or save it. Save as. No, not that. What I want you to do is screenshot it. So I don't know if you have this. It's called snipping tool. I want you to add it to your assignment as well. If you don't have snipping tool, if you look on your keyboard, there's something called print screen on the top. It's PRTSCN, usually on the F8 button. But if you have snipping tool, I don't know if you can see mine, but I can do that.